Hello and welcome to the May update from the Tau team. You're here with me, Fola, and I will now pass it over to Karim for his overview for the month.
Thank you, Fola, and welcome everyone to the May update for the Tau development team. David has been working on two fronts. On the Boolean algebra side, he's actually devised an algorithm for solving systems of Boolean inequalities. And on the TML program optimization side, he continues working on the CQC, and he's implemented the branch and bound algorithm, and then he simplified it by using lambdas. Tomasz has accomplished quite a few things this month. He's finished updating the TML specification for grammar. In cooperation with Umar, they together merged the early parser branch into the master branch for TML, which was a very large task. And at the same time, updated the TML's code base to C++20 standards. And currently he's in the progress of putting all those updates into the TML IDE so we can all play with them. Luca has finished his work on the two CNF data structures and is working on integrating them into the rest of the code base. But since we don't have a blockchain developer yet, we tasked Luca with starting the proof of execution work that will eventually make it into the blockchain. And for that, he started initially working on ways to arithmetize BDD. And basically what that means is taking a BDD and turning it into a polynomial, and which is the first step in the proof of execution work. So that's a good start for Luca on a new task. Juan has continued his work on refactoring the TML code base, which is a major task, but specifically he's been focusing on the type resolution transformation. But he's also been tasked with some initiatives on the Tau research, theoretical research side. Umar, like I said, helped Tomasz integrate the early branch into the master branch. And ever since they finished that task, he's been looking at ways to resolve ambiguities in parse forests. He specifically implemented a lambda function-based callback for traversing the parse forests, and implemented then, before that, him and Tomasz added priorities and preference keywords into the TML.g grammar to help with the ambiguities. And as a result, they were able to implement a get parse tree function that will extract a single tree. So basically disambiguate the grammar from the entire parse forest, which is all the possible ways to parse a program. So that's it on the TML side. On the Agoras Live side, Andre finished updating the framework for the Agoras Live application. It looks much nicer now, and it's in the hands of the tester as of this week. And the tester is banging on it, and he's going to give us his report next week. And he's also finished migrating the IDNI domain to the tau.net domain, which is part of the rebranding efforts that we've done recently. That's it from the development side. Back to you, Fola.
Fantastic. Thank you very much, Karim. I will pass it on to Luis for his update for the month.
Hi, everybody. So I've been working on the weekly MSO sessions for the academic panel, as well as on some topics that are or might be relevant to Tau, such as parameterized Boolean equation systems. The focus during May was on infinite games on finite graphs, especially on parity games because of their central role for game semantics, for automata logics, which is crucial for MSO decidability. So that's all, folks.
Excellent. Thank you very much, Luis. And I'll pass it over to Umar for his update this month.
Hi, team. Glad to share the update. So this month, we have integrated the changes from the early parser into the main master branch. We have also implemented a generic lambda-based parse forest traversal function, which allows to handle ambiguities in a custom way. So we have used that to demonstrate how to extract a single parse tree, implemented specific hints like friends and priorities that can enable a TML programmer to specify the resolution of ambiguities right at the grammar level rather than under the hood in the parsing engine. So we have also developed some tests. Great. Thank you.
Thank you very much, Umar. I'll pass it over to Andre for his update for the month.
Hello, everyone. This month, finally, I finished migrating Agoras Live to the updated framework. It allowed us finally to get rid of most of the bugs data link to the work of the platform on different platforms. And also I replaced multiple components inside the framework to ensure the fast execution and stability. Let me show you in short how the modern Agoras Live platform looks like now. Give me just a second. So this is an updated Agoras Live platform. As you see, it has categories, separated users, public sessions, anything migrated from the old platform. Also, it works just great on the mobile. Always schedule a call on some topic, on some date, on something. Now we have group calls, a personal call with Albert Einstein scheduled. He, of course, will have to confirm it. In my sessions, I will see this group call showing. Also, I have my finance with the current balance, but I haven't logged on to my wallet, so it won't show you. It won't show you it. So this is basically the website. Everything is finally working. We're on track on testing with it, and looking forward to release it to some public beta as soon as possible. Thank you.
Very exciting, very exciting. We're looking forward to getting real people testing it. So what we'll probably do is we'll have some kind of launch where you guys can get your hands on it once we're ready to get the testing done. I will pass it over to Juan for his update this month.
Thank you, Fola, and hi everybody. During this month, I kept working with this type inference transformation that we were trying to solve for TML. This name that is originally called this type resolution, but it's actually a type inferencing transformation, similar to what some other programming languages do have, like CAM. And from the status that we got by last month, we were already having almost 90% of our regression suite working properly with this transformation. But of course, we were aware of some limitations of the previous design, recursive rules that actually TML allows. So in that sense, we had to redesign the transformation in a manner that is still a static transformation, because it will leave the TML program with a polymorphic already solved before execution, but it will need to actually execute another TML program because what we actually need to figure out all the data type dependencies is to actually reach to a fixed point. So if we assemble a graph of dependencies of our relationships and with their associated data types, a convenient way to resolve such dependency graph is with a logical program, which is executed in TML. So what we are basically doing is, from the input program, we've initially transformed it into another TML program, which is sort of a many-to-one mapping of the original program. We executed that program, and from the output of that fixed point, we are able to finally encode the original program with polymorphic types solved in a statically way. So it's non-trivial execution flow, but it is what we are doing. And actually it's stressing TML in ways that align to our major goals, like language translator as a language translator tool. So it is different ways, very valuable design effort that we're putting into our implementation. This is, of course, putting aside a little bit the refactoring effort, but it's also part of allowing at the intermediate representation or at the transformation level, abstraction level that we have in TML. It is part of giving access to the bits of each of our arguments. So it's sort of actually related to what Umar worked during last year with regards to the bit universe transformation, So yeah, it is all engineering effort that we are putting inside our TML core, looking forward to have optimized programs and better resource to do program transformations in a logical way. That's all from my side for this month. Thank you.
Thank you very much, Juan. And I will pass it over to David for his update for this month.
Thanks, Fola. Hi, everyone. This month, I've been working, as Karim said, in 2 fronts, in Boolean algebras and also in TML program optimizations. Regarding the first point, decide if we could have a solution to a system of inequalities or not, but it's not still a necessary condition. So more work has to be done in this direction in order to get conditions for the algorithm. In the other front, in the TML optimization of programs, I've been testing and debugging the implementation based on branch and bound. I have simplified certain points using lambdas, as Karin said. Mainly, some parts of the algorithm are just, let's say, implementations of the command pattern or the strategy pattern and simplify them using lambdas. For example, just for selecting subsets of optimizations to apply to the original TML program, I have implemented breakcodes suggesting from Agoras to do it efficiently. More or less, that's all for the month. Thank you.
Thank you very much, David. I'll pass it over to Luca for his update this month.
Hello, everyone. Thanks for joining. So this month, I finished my shared canonical human-fine data structure that now supports negation, and the last data structure that needed to be finished in order to make the 2CNF universe shared. The 2CNF universe was the data structure base needed, so to speak, where we want to separate 2CNFs from non-2CNF parts of BDDs. So I'm pushing that work forward now. And at the moment, I'm integrating the shared data structures into the existing code. And yeah, that's what I'm doing on the implementation side. On the second front, as Karim mentioned, and I think he explained it very concise, I've started working on the proof of execution. And this at the moment comes down to find proper ways to encode a BDD together with quantification and operations into a polynomial in such a way that we can do the things that we need to do with the polynomial in the most efficient way possible. That's exciting things, and also to be finished hopefully next month. And so looking forward to those tasks. Yes, I'll pass it back to Fola. Thanks.
Thank you very much, Luca. And I'll pass it over to Tomasz for his update for this month.
Thank you, Fola. Hi, everyone. This month, I've continued to work on the early parser, TML's grammar specification file, and also refocused the TML editor. I've actualized TML.g, which is the TML's grammar specification file, by adding new priority and preference features added by Umar. I finished conversion of the parse forest to raw program structure. I merged all the early parser changes into the master branch, and I also updated TML's code base, build scripts, and JavaScript build to support C++20 standard. And yeah, I've also fixed several bugs. For example, there was a serious bug in detecting contradiction, which was found by Andrew. So thanks for that. And currently I'm working on syncing up the TML editor with the up-to-date TML version, and I'm fixing bugs we found in the editor. So that's all from me this month. Thanks.
Thank you very much, Tomasz. And I'll pass it over to Ohad to wrap up the dev call for May.
Well, I continued working with Professor Fanconi on the software specification language that we have. Also worked with Dr. Kramer about aspects from social choice theory that related to Tau. And I continued my research on Boolean algebra homomorphisms in order to enhance even more the capabilities that we have in the new languages that we have. And I started with a plan on how to implement those new languages that were discovered. Yeah, and that's all.
All right, thank you, Ohad, and thank you to you for tuning in to this dev call from the Tau team. And as I said before in the last video, we do have a merch and Agoras token competition ongoing. So I will let Killian pass on the details in Telegram and on our socials of how to win. And again, thank you, and we'll see you on the next call. Cheers.